This video is about adding vectors graphically, and the word graphic you'll probably recognize as a picture. And what we're going to do is we're going to use our concept of vectors, which are things that have magnitude or a size, which are usually some type of number and a direction, to essentially make a picture. Sometimes it's simple. Sometimes it's, just to try to give you a visual here, we have an arrow going to the right. So maybe this is our first vector, which is some distance going to the right. And then we'll have another distance going to the left, and then we kind of add them up. Or let's do it this way. Let's say now we have another distance going downward. And this is kind of like a little map of where we've gone and the route we've taken. Well, when we're dealing with vectors, we care about the beginning and the end. The way we went to go about there, it doesn't really matter. So what I'm going to do is now show you what we would call the resultant. That's the combination of these two vectors. So this red arrow represents the distance traveled if you'd kind of go as a crow flies, going from point A to point B. We took a very simple route here. We went to the right and then we went down, but we could do any combination of stuff. The only thing that matters is my beginning point and my ending point, and that establishes what we call a resultant. Now, we've done a couple different things here we should probably make sure we talk about. This would be what we would call the head. Oops, I got to get off my arrow tool. Get a color here. This is what we would call the head to tail method of adding up vectors. And if you kind of look, we started with the first spot. Here's our starting location. And then we just put our vector there. At the end of the first head, we put our next tail, and then we drew the next one, and this is where we ended up. I can make the word end there, and you can see the total resultant is this red line. Oops. I'm trying to put this back down. This red line is what we call our resultant. Sorry about the messy handwriting. But what we need to do is figure out how to get these resultants. That's kind of our end product here in this case, where we have something showing a distance. Now, sometimes it's very simple. If I just have two vectors, one going to the east and one going to the west, it's pretty easy to see how those two things work out. And those you may not need to do a graphical representation of, but we'll just show you one just to make sure it makes sense. So I'm going to start off saying I have 5 meters to the east. Now notice I went down to my ruler and I started at 0 and I just went 5 of these units over to the east. I can use any units I want. I can use inches, centimeters, feet, whatever's convenient for the workspace that I have. And then what I'm going to do is come back, and off of this head I'm going to draw my next tail, and I'm going to say I'm going to go 3 meters to the west. So now I have to go to where this number 2 is. So I went 1, 2, 3 units west. And now what is my total resultant? What did I do? Well, if I start at my beginning vector and go from its tail to the final vector's head, that right there is my resultant. And this is pretty simple to see. It's just going to be 1, 2 meters going to the east. So if I would draw this out, I would just simply say, okay, my final answer here is 2 meters east. Okay, and that would be what the red one represents. And those are easy. Those are ones that I'm kind of showing you just to make sure you're understanding what we're talking about. I guess the main thing you want to make sure you know is this head to tail method. You just simply pick a point, you put your first vector there, draw it in the direction it's going, and then you end up somewhere, and then from the first tail to the last head, that distance represents your resultant. And the direction this was going was east. It was very simple. This one's not as easy. We would have to take a protractor and measure that. We're going to kind of cover that in a future example coming up right here. Here we're talking about a cat, and this cat's going to walk at 90 degrees, which I know most cats don't do, but this cat's going to walk 20 degrees or 20 meters at 0 degrees. Okay, and 20 meters is a little bit more of a difficult distance for us, at least with our rulers, because we don't have a 20 centimeter ruler. It only goes up to 15 centimeters. So what we might want to say is, okay, we're going to say one of our units equals 2 meters. And the reason we're doing that is we're scaling this down. We're drawing an actual scale representation of what the unit's going to be. So I have to use a 2-to-1 ratio because I don't have something that can go out to 20. But it's pretty simple. We're just going at 0 degrees. Now, I guess before we get into this, we need to define what our degrees are going to be. And to do that, we're going to keep it very simple. You need to think about a circle. And then with the circle, there are 360 degrees. I'm just going to use these little green arrows here. And what we have here is kind of our coordinate axis. So there's X and Y planes and things along those lines. This comes from kind of the math field. Oops, I don't want to do that. I want to do my pencil. So I got that back. Now I'm going to bring this up. This right here would be 0 degrees. This would be 90 degrees. I'm sure you can recognize the right angle. This would be 180 degrees. And this would be 270 degrees. And then once you get back to here, well, now this is the same as 360 degrees. So you can kind of see that's what we have to base our angles off of. There's a lot of different systems out there. This is what I feel is the simplest because each of these are mentioned. I've seen things like east of north and north of east, and that we spend a lot of time just trying to figure out what that is. This is something that came from math. Many of you have experienced this before, so it's not that big of a deal. So if we kind of look back at our cat now, 20 meters at 0 degrees. So what we need to do is just simply make a vector. If we're going 2-to-1, it's going to be 10 meters or 10 of these units then going to the right. So I'm going to pick a appropriate thing. I'm going to kind of hook it up down here. And there's our 20-meter vector, okay, going at 0 degrees. Well, in this case, 90 degrees is pretty simple. It's going straight up. And I'm just going to put another vector there. But here I need my other ruler. So I'm going to click over here, bring this ruler over, and I'm going 15 meters. So not as simple as before, because I'm going to have to go 7.5. So I'm going to put that at the end there. Now I don't normally have to have 2 rulers. I could rotate this one, but it's easier just to move this up. Now I'm going to simply go off the end of this head and go up to the 7.5 point. And there's my second vector. So there's, I guess just to label this to make it a little easier. Oops, that's not what I want to do. Gotta put back my pen here. This is 20 meters, and this is 15 meters. Let me get rid of my rulers here now that we've used them. That's pretty simple to see. Now, many of you want to jump right into the algebra of this. And in this case, it probably would be easier to do the algebra. But for now, let's just kind of work with our picture. We need to figure out what is the result. How do we get there? Well, I'm going to bring back one of our rulers. And we'll use that in just a second. To do this, again, we go from where we started to where we ended. And we draw another line. So it's very easy for me to draw a line because I can use these little tools that always make straight lines. But you might want to use your ruler. And now you can see, okay, we're going up at that angle. This is, again, as the crow flies from point A, or the starting point, to our ending point. What we then need to do is figure out how far is that and how far do we go. So to do that, we're going to use our ruler again. Now these rulers can rotate. And move that up here. It's the wrong edge, but I'll just move that over in a second. And you can see that this covered about 12.5, but then we have to double that. So it's about 25 meters in this case. So this was 25 meters when we measured it off. Because remember, 1 unit is 2 centimeters. That doesn't give us the whole picture now because this is only a scalar until we give it direction. So I'm going to click on my protractor, and this is starting to get a little messy, but you can probably kind of see that when we put our protractor here by the vertex of our triangle, that this is approximately 38 degrees. Let me get the ruler out here to try to help you out a little bit. Actually, the ruler says it's about 35 degrees. There's a protractor function on there too, but I wasn't planning on using that. So, actually, as I kind of look at that, that might be 36 degrees. But let me bring this back down here. So, our total vector here, when we add this up, is 25 meters at 36 degrees. So, again, pretty simple. I know a lot of people want to jump right into the algebra of it and kind of have those two going that way. Let's look at one where the algebra is not as simple, and then we'll probably wrap this lesson up. This time we have our same cat. He's walking 5 meters at 30 degrees, and then 4 meters at 200 degrees. So this is not as simple. We got to figure out how long these arrows should be. So again, I'm going to jump on my arrow tool and kind of just start from a convenient point. Now we want to go 5 meters at 30 degrees. What I'm going to do is kind of, red is our resultant one. Let me make sure I get to black. Let's go black. I'm going to establish my 30 meters first, and then what we'll do is we'll subtract those after that. So there's my 30 meters. I'm going to move my protractor out here. Oh, I don't want to do that. Just got to move it. And then I'll bring this in here. Now it's only 5 meters, and we have that on our scale. So I cheated and worked ahead and put my ruler at 30 degrees. What I thought was 30 degrees. And I want to now shorten this up. So I'm going to make this only 5 meters. Okay, so it's 5 meters at 30 degrees. Now I'm going to go 4 meters at 200 degrees. So what I do is I take my protractor, I go right to the end of that. Now I'm going to go at 200 degrees. Now, what we notice is there's not a whole 200 here. So what I have to do is I can add on to this. And you'll see we almost end up right where we started. I don't know if that was the best example to pick. But we're going to go back down here 200 degrees. Oops. Now I'm going to go back to my arrow tool so I can click this and try to move this out of our way a little bit. Okay, so there's our two vectors added up. What we want to know is, well, where do we start and where do we finish? And it turns out it looks like we almost went straight west. So what I want to do is, all right, find my resultant. I'm going to use this red arrow again. Go from where I start to where I finished. Okay. So to find out the total distance I went, I need to use my ruler again. So click on my ruler, rotate this up a little, rotate it down that way. Now I've got to move it. So what I'm going to do is I'm going to take this whole vector arrangement here and move this so it's in a better spot. It's the beauty of computers here. Now, what I'm going to do is try to move this, and this edge right underneath here, and then I can rotate that. And you can see that's 3 meters, but it's not exactly west. It's a little bit south of west, a little bit. Oops. My crazy rotating protractor over here. So I'm going to take this, I'm going to move it over here, put this right in the vertex of the triangle. Computer's lagging a little bit with this. So the first thing I established is that I went 3 meters. Now I want to just pop my ruler out of here so I can figure out my angle. You know, it's probably going to be a little easier if I almost draw a line right off that and extend it. So I'm going to draw a little dotted green line through this red line to help us out. And you can see that we ended up going, this is 180, this is 185, maybe 184 degrees. And if I just put this, we're at 184 degrees. That one would have been a lot harder to do with the math. There's not a right triangle that forms here. So you can't use your typical sine, cosine, and tangent to kind of work through that. So that's our little lesson on how to add vectors graphically. Hopefully you can work through that, and I know there's a couple snafus where something wouldn't move, but for the most part I think we got the idea across.